we did an example with the product rule, so you can almost hear the quotient rule galloping towards you after that. Here's our function. The top is sine 3x, the bottom is cosine x squared, and so the quotient rule tells us that our derivative for this is going to be, briefly, it's bottom d top minus top d bottom over bottom squared, or you might have learned gf prime minus fg prime over g squared. Let's see what we have here. Our bottom is cosine x squared times the derivative of the top. Now careful, chain rule happens here. The derivative of sine 3x is cosine 3x, first of all, times the derivative of the 3x, which is just 3. So that's our first. This is our second, or sorry, d second. Then we do, or sorry, I should be saying bottom d top is more like the truth. Bottom d top minus top, which is sine 3x, d bottom. The derivative of the bottom, it's a cosine first of all, so its derivative is negative sine of exactly what's already there. Then the chain rule says now do the derivative of what's inside this, which is x squared. Its derivative is 2x. So bottom d top minus top d bottom all over the bottom squared. So instead of cosine x squared, we're going to have, this is crummy notation, I apologize, cosine squared x squared. That's about the nicest we can make that look. So now, if we're cleaning this up, this 3 is a coefficient. We can put that all the way out front. These cosines have entirely different arguments, so there's really no way to combine those. We have cosine x squared times cosine 3x. Nothing to be done with that. For the second chunk, we have a negative sign, another negative sign, and a 2x. So the negatives cancel, and we're just left with plus 2x. And then we have sine x squared and sine 3x. Negative and negative cancel. We got the 2x. Yeah, that's everything. I switched the order here because this one I went x squared and then 3x, so I wanted to have the same order here. That isn't going to help us in any really long-term way. I just thought it was nice that those matched up. And downstairs we have cosine squared of x squared. I'm not sure we can do anything to make that any better. There are no common factors in here. Here there's a cosine x squared, which could cancel against this, but there's no cosines over here. I don't want to divide everything by cosine x squared and create a tangent in this part. I don't think that's actually an improvement. So this, while it looks a little ugly, is probably about the best we can do with this. And fortunately, they don't ask us to plug a value into it or anything, so we get to that point, and that's where we can stop.